we are going to see is first a content what the problem Diva solves, the setup, how it looks like, how it works, Diva, like overall. And then we will see the product itself, first the staker UI, and then the operator part, which is, we will split it in two parts. First, the registration of the operator, and second, it will be like having how it is having a distributed validator running. Well, first, the problem we found is that to have your own validator, it is required 32 ETH. That's a bit higher that many people can afford. So another problem that we are trying to solve is that the complexity of running your infrastructure to do the staking, to run your own validator. And this, how we do it is through LSD and DVT. With LSD, we have different benefits, like it's economically more, it's better. And also, we have resiliency because of DVT, and yeah, and is more decentralized. So we made, as you will see now, we made the product very, very easy, very straightforward, and very visual for everyone to be able to do it. And because we want to lower the entry barriers for operators, the requirement of collateral is only 1 ETH. So basically, with only 1 ETH, anyone will be able to be part of the validation in Ethereum. So how it works? We have two main actors, the stakers. Stakers are those that just stake ETH and receive Diva in return. They don't need to worry about running their own infrastructure. They just receive the Diva, and this Diva, the synthetic that we are releasing, is doing all the validation stuff automatically. And the operators. The operators, they also put ETH, but because we don't want to trust them, we block this ETH and use this ETH as a bond. So the Diva remains safe economically. So basically, we have the staker and the operator. When 16 and plus 16 ETH are deposited on the contract, that is enough collateral for a new validator to be deposited in the consensus layer, in Ethereum. So through the smart contract, a new validator will be created. But this validator, the private key of this validator is not in a single node, in a single operator. Nobody has this private key of the operator, but this operator is somehow split in different key shares. And each operator of the set, of the distributed validator, will keep these private keys, this share of the set. So in the product, what we will do for convenience, and we will do the very same thing for the testnet, for everyone to be able to do it, we are having a Docker composed with the images. So basically, here in the image, you can see the different parts. First, the validation that usually comes with the consensus client, and then the execution clients. So on top of these three parts is our client, which is Diva client. Diva client is sit on top of them and is talking to, through our own P2P network, is talking to different others Diva clients. And then let's jump, this is an introduction, and let's jump into the product itself. First is we will see the staking. It is very, very similar to any other staking platform, where the staker just can go to his browser, go and stake any amount he wants. Oh, first we need to connect the wallet. So here we select the wallet we want to connect, and as you can see, it's just one click. It's very, very easy. And oh, what's happening here? Oh, we don't have internet. Let's see. Can you share internet? We have a screenshot in case this doesn't work. We are trying for a minute. Yeah. ¿Tenemos? So, okay, here is the staker UI. Now let's try to transact. So I put, for example, 1 ETH. This is in Gorley, by the way. Let's stake 1 ETH. Apologies. Otherwise, we will just... Okay, we are having trouble with internet. No worries. We will skip this part. Basically, it's as any other staking platform. So we will have we already have it if you want to test. It's a public website where you can just do what I was trying to do. Just using the staker, it's a transaction, and you will get the Diva, the LSD token in return. Also, an stake is also available already, so you can try out. So this is the staker part. Now let's see the operator part. No. So in the operator part, we had the workshop ready, but because of we are having internet issues, let's use the images. So basically, the flow you can see it in the left side here. So welcome, connect wallet, check connectivity. It's very, very straightforward. It's click by click. Let's go. So you have connect wallet. You just use your MetaMask to connect as in the staker UI. Then you will see how the Ethereum clients that will be already automatically installed along with the Diva client. So you need the clients to be connected and synced. At the very beginning, you will find the clients in a status syncing, and then it will be connected. And just click register.
So when we register a new node in the Diva protocol, we need to interact with the smart contract. So at this point, we made a transaction that links this node with the operator. And we need this because all the peer-to-peer network use this identity. And yes, when we finish the operator registration, we can we have enabled this dashboard that that show us the information about our signers. If we, well, in the real user interface, we could add collateral and get new key shares, new signers that are parts of new validators,
Yes, for each ETH you deposit here you can deposit ETH. So basically for each ETH you deposit, you will be part of one of the private key shares. So you will be part of one different distributed validator each time you deposit one ETH. This is how it works.
And, well, and this is a real Diva client, a node, a validator that has 5 Divas as collateral and is working on 5 validators that they are working right now. This is it's a screenshot, but it's for real. This is.
Yeah, it is working in Goldly right now. Unfortunately, we were not able to show because of internet, but yeah, we just did a screenshot for you to see.
Well, this we created this operator UI because we expect to onboard many different operators based on their expertise. So we want to onboard professional operators that will probably not use this user interface, but we also want to onboard people with ease, but with not the technical expertise to run their own validators. So this is the what we consider a helpful tool to join this task.
Yes, please join our Discord. Here you have the QR code. We are releasing a testnet very soon, so please join us. And if you want to ask any question, it's time.
So I have kind of a technical question about the staking, I guess. Like, so when you have one Ethereum and that's distributed among a 32 ETH node, how does the secret work? Is that like Shamir's secret sharing, or how do you maintain like a validator among 32 different entities?
Can you repeat the question? You're asking how we did split the private key?
Yeah, essentially, how does the validator?
We are doing a DKG, distributed key generation, and that's how we do it. Then for each duty, because each node will not have the private key, but one of these key shares that were released after the DKG. So then we use threshold. So for example, if we have 16 nodes, determinate number need to sync the duty for the validator to meet to do his work. Yeah.
Okay, and I guess it's kind of like how people can do a multi-sig with like a 2 out of 3 or something. I guess you could do like a 24 out of 32 to sign something. So not everyone needs to be online.
Can you repeat, please?
I guess what is the threshold for how many of those?
Yeah, the threshold, because we are right now in testnet, we are doing different options, so we cannot say a number right now. We are doing different kind of studies to try to understand what behaves the best. But we have different alternatives already, and we'll release very, very soon.
Thank you.
No worries.
So you said that you haven't thought about having the number, the threshold, what is the exact number, but don't you think that will also affect the overall security assumptions of the protocol, and what will be the trade-offs?
Can you do it a bit higher? I can't.
Okay. So you mentioned about the that you're working on finding the best number for the threshold of signatures. So don't you think that will affect the overall security assumption of the consensus? And what will be the performance trade-off when you have multiple nodes have to do this multi-party computation?
So there are two kinds of performance. The economic performance will remain the same as a normal validator. Actually, we are more resilient because of characteristics of DVT. So it's more resilient. So if you have one of the nodes and your node failed for whatever reasons, still the distributed validator will keep working. So will keep doing his work. So economically, the performance, it seems to be like the same.
Yeah, in terms of latency, because we have this epoch interval and Ethereum, and so now when you have multiple nodes have to sign and they have to communicate between each other, does that affect that?
I think well, when
Yeah, so that's why we need the studies, because we need to set up exactly the size of a node. There's going to be a really nice balance between the size, the threshold. You cannot infinitely scale the number of nodes, because then you're going to increase the latency. So if you have 1,000 nodes, then you have many communication complexity. So you have to set up exactly the right node to have the resiliency plus the latency constraints that you need for Ethereum. So yeah, that's why Franjo mentioned before that we're doing these studies to get exactly the right number. And we cannot give you exactly what is going to be that number, because we are still in the process of studying. But yeah, you're completely right. It affects latency. And it's a balance between resiliency and latency. You're right. Yeah.
But not only. There's also an aspect of cryptoeconomic security. So when you're lowering a threshold, you're basically allowing people to do a levered attack. So in the end, we are trying to find an equilibrium between optimizing for uptime, but not too much latency, but also it needs to have enough security. So we had a talk a couple of days ago talking about this. I don't know if it's recorded, but we went in detail into what it means to have a griefing attack, what it means to have a levered attack on Diva only, on Ethereum as a whole. So those are all like really important red lines that we've drawn on the protocol.
So let's say that you guys choose to do like a 2/3 quorum for signing for attestations. What prevents me from joining the network and then just free riding forever?
Yeah, so that's why the collateral is important. And in that case, the economics play a really important role. So the tokenomics will help you not to be incentivized towards that thing, because it's going to cost you money, and basically the money that is going to be taking will be from your collateral, and a staker will never lose like the capital, basically. The thing is that you could still think, oh, maybe I create this attack, all the damage will be done by me, and therefore all the collateral will be taken from me, but you really don't have much incentive other than maybe creating some kind of sorting or something on the network. And as Pablo also pointed in one of his talks, that maybe you want to attack the network by doing some kind of economic attacks, more like trading, whatever. But that would be like the main disadvantage. But you cannot really do a free running and say, I forgot about the keys, because you're going to pay for it. You're going to, like, the tokens will be the ones taken from you, and a staker will be fully protected from your collateral. That's why collateral is important. There is a really important correlation between collateral and security and trustless of the protocol. And yeah, my talk a few days ago, we were deeper onto this topic. So if you wanna, I don't know if it was recorded, but if it was, I recommend you to take a look.
Actually, maybe for anybody interested, we're having a dinner tonight. We're going to talk again about the economic aspects. So if you missed the previous talk and you want to learn more about where are the red lines and where are the security trade-offs that we're doing between performance and economic leverage and attacks, come today. It will be from 6 to 9. We'll have burgers, we'll have beers, a beer-to-beer network. So just ask me and I will give you an invite.
Any other question?
I just think that will significantly affect the security assumptions for the crypto economics. That's like a red line that we need to look at. For. Yeah, that's just a comment.
Anyone else?
Thank you.